Partners, kind of relate to the other question. It sounds like a weird question, but think about it. What is this? Are there letters inside of us?
No.
Are there actual letters in eggs and sperm?
No. Yes.
No. Yes?
No.
Maybe. Okay. Now, this is what I want to ask. I'm going to give you 33 seconds. Okay? To tell me, in real life, what does this look like? Okay, in real life, what do these letters look like in real life? Go. Okay. In real life, what does this letter actually look like in real life?
Letters, the ABC.
No. Okay, so what does that look like?
It's a
piece of information from the chromosome? Okay. So you think that's what it's going to look like in real life? Okay. So Irving Q is going to tell us what he thought. What did you say? What is this thing root? You know, many of you said there aren't letters in human beings. You know, when you take out eggs, we're not going to find letters in there. So what does it actually look like in real life?
A piece of information from a chromosome.
He said it's going to look like a piece of chromosome. It's going to be like a little part of a chromosome. Okay? Natalie, what did you say, or somebody in your group say? What is it going to actually look like in real life?
Like
You do know.
a line?
Like a line? Why did you say a line?
Because of the DNA.
Okay, so you're saying this letter is going to look like, in real life, a part of DNA? Okay. Who also thought that? Who agrees with Natalie that it also is going to look like a piece of DNA? Okay? Who agrees with Irving Q? That it's going to be like a little piece of chromosome? Who agrees with both of them? It's essentially the same, right? Because David told us earlier, chromosomes are just coiled up DNA. So, Irving Q, Natalie just said, this song, you're being ridiculous. There are no letters inside human beings. So why do we use letters then? Okay, talk about it with your partners real quick. Go. 22 seconds. Why are we using letters why are we using big B and little b? Why are we using letters when we're talking about DNA? To describe what is they. Okay, to describe what the offspring is going to express. Okay? Alright. Randy, what did you or somebody in your group say as to why do we use letters then? We're talking about pieces of chromosomes. We're talking about pieces of DNA, like Natalie and Irving Q said. So why are we using letters?
Just to represent the genotype we will have.
To represent the genotype? What do you mean by that? To represent something, though, right? That's your idea, that these letters represent something. Joshua, you want to add something?
They represent like what type of genes you will have. Like, big B and little b, little b, big B, little b, and also like which is dominant and which is recessive.
Okay, so Randy gave us the idea. Okay, these letters, there are no real letters in there. Okay, you can look all you want, but there's no letters. But these are representing. He said the genotype. These represent what? The type of genes that a person will have. Okay, that's why Natalie and Irving Q said, in actuality, these look like little pieces of chromosomes. Okay, so let's pick another kid. What's in there? Okay, Mom gave big B, Daddy gave little b. Get in there. Okay. Okay. So this is baby number 1, baby number 2. Okay. Look up. This is offspring 2, O2, not for a long time. Okay. All right. Mommy gave big B. Maybe like 20. Okay, big B. And then Daddy gave what? Little B. Little B. Ooh, I have a really good question right now.
What?
Please think before you answer, okay? So when I start the timer, don't feel like you have to answer right away. Think about it before you answer. At this point, look up. At this point, do you feel we have enough information to figure out, to determine the genotype of the parents? Okay, let me repeat the question. Do you feel that at this point, do we have enough information to figure out the genotype of both parents, mom and dad? Okay, go. 22 seconds. And then why or why not?
Make sure
What happens with the mom? I think we can still more.
Uh-oh, we have a disagreement. We have a heated argument going on right now. I got scared. Okay, so is it possible at this point to figure out the genotype? Who says yes? Yeah, we can figure out the genotypes of both parents. Both parents. Raise it up high without bending your elbow. Raise it up high without bending your elbow. Okay? Who says no? We don't have enough information to. Okay. Raise your hand without bending your elbows. Okay. All right. So, Kelvin. Kelvin. So, what do you think? Do we have enough information to figure out the genotypes of the parents at this point?
Yes, because for Bob, we already know that he's homozygous recessive because there's no baby in there. And for Sue, we could infer that she's either heterozygous or homozygous dominant.
Okay, let's see. Let's hear another explanation. Thank you. Josh, and then we'll go to Lisa.
I would say no, because like the dad Bob can contribute like more recessive cells and dominant cells, so we don't know yet.
Why don't we know yet?
Because they could the dad he can give like different he can give more than one specific trait. Like there's lots of B's and lots of big B's and that.
Oh, there's lots of little bees and lots of big bees?
Yeah.
It could be that he has big bees, but we haven't gotten to it yet. Okay. Can we figure out Sue's genotype?
Yes. Exactly.
Stephanie, why did you say we can figure out Sue's genotype? Oh, I thought I heard a yes here. Oh, yes? How do we know already Sue's genotype?
Because we know that because she has a little b and a big B, and we could infer that it's heterozygous. Even if she gets little b anyway, she's still gonna be heterozygous because she still has the big B. And if she gets the big B, she's still gonna have the little b, so she's either way gonna be heterozygous.
Okay. Lisa, how are you going to explain it earlier?
We can't tell because Bob can still have big B's.
He could have some sperm cells that have big B's. We don't know yet.
But we can't tell what Sue is. She's heterozygous because she has big B and little b. No matter what, like if she were to express sperm lines, she can still be heterozygous.
So what do you think her genotype is?
Heterozygous.
You think she's heterozygous? You think she's heterozygous? You think she's heterozygous? Okay. So people think that Sue is big B, little b, and Bob, maybe some people said we don't know yet. Okay. But this is correct, but I still didn't receive an explanation clearly why we know for sure she's heterozygous. Anthony, go ahead.
We know why she's heterozygous for sure because on the first one she got a little B.
She was able to contribute a little B. Okay.
She got a little B, and then on the second one she got a big B.
Who's she?
Oh, Sue.
Sue was able to contribute. She was giving, right? She was able to contribute big B. So how do we know at this point that she must be heterozygous?
Because she got one dominant gene.
Okay, so she has egg cells that have both alleles, okay? So some egg cells have big B, some egg cells have little b. Okay, let's make another kid. Oh my God. You get an egg, one egg. One make the other one.
So sad.
Okay, open it up.
The baby's gonna be ours.
Okay. Okay. The mom contributed one big B, and then the dad small b. Okay. Small b. This is the third kid.
Whoa. Dang. Triplets.
No, that's okay. So offspring 3. Mom gave, what was it?
Big B.
Big B. And then daddy gave what, Carlos?
Little B.
Little b. Baby has what color eyes?
Brown.
Brown eyes. Okay, has brown eyes. Okay, let's get another baby.
Whoa.
Don't beat it. Okay, open it up.
Not just one.
Open it. Small b. Mommy's contributing a small b. Small b. And then?
Big B.
Oh!
Finally.
Daddy gave a big B.
For the first time.
Daddy gave a big B.
What was that? They're both. So the baby could be any.
So offspring number 4. Mommy was what?
Big B. Little B.
Little b.
And then
Mommy was little b. And Daddy was what? Jesus? How about
Big B.
big B? Baby's gonna have blue or brown eyes? Brown eyes? Okay. So at this point, can we figure out the genotype of Bob?
Yes.
Okay. Who says yes? At this point, we can figure out the genotype for Bob. Raise your hand without bending your elbows. Who says not yet? Who says not yet?
Oh yeah.
1?
What?
You know? Okay. Who can tell us what is the genotype for Bob at this point? What is the genotype for Bob? What is the genotype for Bob? What is it? Justin, thank you. What is the genotype for Bob? How do we know? And how do we know? Think back to what Anthony said about why we knew at this point that Sue was big B, little b. Okay? At this point, many people said, oh, now we have enough information to figure out the genotype for Bob. Why do you feel we have enough information now?
Because
Think about it. I know you know this. I think it's difficult to articulate it, but how do we know at this point that we have enough information to figure out the genotype for Bob? Okay. No, we can't say that in my class, right? So we're going to come back to you. All right, Randy.
I say yes, because you can tell from Sue that it's a double. And Bob is going to be little b, because there's more little b's than big B.
So you think Bob is homozygous recessive? Okay. Randy said Bob is homozygous recessive. Who also agrees with that? Okay, 1? two people. All right. Who said something different? Okay. Who thinks Gabriel? Okay, what do you think is Bob's genotype at this point? And how do you know?
It's
Okay. So he thinks it's heterozygous, big B, little b. How do you know that?
Because there's mostly big B's and B's.
You mean mostly big B's and little b. So right now we're only looking at the blue, right? Because we want to talk about Bob. How do we know at this point that his genotype is big B, little b? It might help. I'm going to give you 33 seconds to just practice saying it to the person next to you. Okay, go.
See that heterozygous? I say it's heterozygous because he has one possible chance of brown. Yeah. Because he has only one B out of 4 trials. He has one B. What do you guys think?
All right. Thank you for quieting down. Thank you for the sound of the alarm. Okay, Gabriel, now that you've had a chance to kind of warm up and tell people at your table, what do you think? Why did you say that Bob's genotype must be big B, little b?
Because there might be a slight chance that he could get brown eyes.
There's a slight chance that he can give brown eyes?
No, get.
Yes.
Oh, no. I mean, get.
Give? How do you know? How do you know he can give brown eye traits? Very good. How do we know that? Because he was able to give what?
Brown eyes to one of the babies.
Okay, which one of the babies? 1, 2, 3, or 4?
4.
4? How do we know that he was able to give him a brown eyes trait?
Because Sue had recessive and Bob had
Because Bob gave what kind of a allele?
dominant.
Yeah, Bob was able to give a dominant allele, which is why we know, okay, so he has the ability, some of his sperm cells has this information, the brown eye information. Okay? Kevin, what did you think?
I don't think I understand.
Okay, so Kevin thinks it's homozygous recessive, so now there's 3 people who think that. Why did you think that?
Because so far Bob has more recessive and Don has one.
Okay, so out of 4, there's more recessive alleles, which is why that he might be big B. I mean, sorry, little b. Okay. Go ahead, Lisa.
I disagree with him. I say Bob is big B, little b, heterozygous, because once you see a big B and one little b, you can tell it's heterozygous.
Oh, so as long as you see a big B and a little b, you know this person must be heterozygous. Okay? Do you want to say it in your words?
Yeah. Oh, I agree with Lisa because on the 4th baby, he contributed a big B, and on the other babies, he contributed a small B.
Okay, he said in the 4th baby, Bob was able to contribute a big B, a dominant allele. And even though in the first 3 babies, he only contributed a recessive allele. So that means he has them to give, right? Can you share what you don't have? Can you share what you don't have?
No.
If I'm like, hey, does anybody want donuts? And everyone's like, yeah, I want donuts. I'm like, okay. Because I don't have donuts. I don't have donuts to give. So it doesn't matter if you want it or not. I don't have any donuts on me. Don't look at me. Hey, but does anyone want cupcakes? But I don't have cupcakes. Okay, you can't share what you don't have. So if Bob does not have a big B or a little b in any of his sperm cells, he can't share them. Okay? Right? So if Bob, let's say, if Bob was little b, can he share a big B? No. He doesn't have them. It's like me saying, hey, does anybody want cupcakes? But I don't have cupcakes to give. He doesn't have a big B to give. He can't share what he does not